Okay, so the two problems we want to look at are this one and this one. Then I'll talk a little bit about this one and this one, but we've already been over that particular topic. The main of this, 2x minus 8 has to be greater than or equal to 0. Because if it's less than 0, you can't do the square root. So we solve this. Here we get x equals, well, okay, I'm just going to go ahead and solve this. I'm going to add 8 equals 8 to this inequality. That's going to give me 2x greater than or equal to 8. Then I'm going to divide by 2. I can't subtract 2, and that would not affect this 2 at all. I have to divide by 2 if 2 is multiplied. 2 is multiplied by x, so we can get x if we divide that by 2. We get x greater than or equal to 4. So that would mean x is in the interval from 4 to infinity. And remember, here's 4. Here is x greater than or equal to 4. Remember this picture of an interval, okay? Then for the denominator, let's see what it does. 4x plus 6 equals 0. That results in division by 0. I'll say 4x plus 6 equals 0 is not permitted. So we solve 4x plus 6 equals 0. And we do the algebra, and we get x equals negative 6/4, which of course can be reduced to negative 3/2. So x equals negative 3/2 is not in the domain of this function. Now, as it turns out, x equals negative 3/2 would be over here. So it's already not in the domain of the function. Okay. So the domain is just the interval from 4 to infinity. Okay. Now we want to find f inverse of x. Four x, no, 2x plus 6. Thing I told you to always write out, which x and y. Nobody wrote out, although some people got it right. Okay. If you're getting it right, maybe you don't have to write that out. If you didn't get it, take my advice. It was good advice. Okay. There's the basis. Remember, we have the tables and we put the x's and the y's. Put the x's where the y's were and the y's where the x's were. And we got a graph. And I could have asked you to do this with a graph as well. Okay, anyhow, we switch x and y. So we get x equals 2y plus 6. Then we solve for y. Then let's rewrite it. Subtract, add -6 equals 6 to this equation. We get x minus 6 equals 2y. The 6 isn't subtracted from the 2. You can't subtract anything from this 2 because 2 is multiplied by y, and you don't know what y is. It doesn't work. Okay? If you're subtracting a number, it has to be subtracted from a number, not from an expression that has a variable in it. Okay, so x minus 6 equals 2y. And we reverse that because we kind of like the way it looks. If the thing we're solving for is on the left, then we divide 2y by 2. Y equals x minus 6 then over 2. So f inverse of x is going to be x minus 6 over 2. Now, how do we test whether that's a good inverse? Because that comes down to checking. And I didn't ask you to do that, but I did ask you then to determine whether these are inverses. Uh-oh. Thought I had more clean board than that. Gonna have to take a minute. Okay, so we've determined that if we've done everything right, the inverse of f of x equals 2x plus 6 is x minus 6 over 2. Well, then, what is f of f inverse of x? So write that down and see if you can work that out. Okay, now most of you are having trouble with this question. And it's an important question, whichever class you're in. This is coming up, and for some classes, it's coming up real soon. So f of f inverse of x is what? Well, let's start writing the rule for f of x. Now, if we write f of f inverse of x, then we've replaced x by x inverse of x, and we've got to replace this x by x inverse of x. F x, anyhow. Does that make sense? We're simply taking the definition of f of x and replacing x by f inverse of x. So now we've got f of f inverse of x. There it is. But of course, there's more we can do because f inverse of x has its own formula. Okay, just checking. Zoom doesn't always show me that it's recording. Okay, that equals 2 times x minus 6 over 2 plus 6. Okay, because f inverse of x is x minus 6 over 2. So I replace f inverse of x here with x minus 6 over 2. Now somebody wanted to replace it here. I think it's simpler if you use f inverse of x first because it's a little less confusing, but it could be done either way if you avoid the confusion. And well, I can simplify this. This is a fraction. Well, this is a fraction. And I see I've got, for sure now, when I put it in this form, I see I've got a 2 in the denominator of this product and a 2 in the numerator. Now that only works if these things are multiplied, but since they're multiplied, that 2 can divide that 2, and that gives me just x minus 6 plus 6, which is x. That confirms, well, it doesn't quite confirm that these are inverse functions, but so far so good. F of f inverse of x is equal to x. Now we also have to do f inverse of f of x. So f inverse of x equals x minus 6 over 2. So that f inverse of f of x would equal what? Write that out for me. Just write f of f inverse, write this and write this, and then tell me what this is equal to, just to see if you're getting it. Try again. Zoom, this went away, but then it came back. So I don't know what's going on. Really need a better camera, and I think I've got one. I just haven't been able to shake it down yet. And I need some alternative to Zoom. Okay, so of course, it might not be Zoom's fault. This might be something going on with our network or whatever, with our connection. Did another crazy thing. So I hope this is being recorded and I hope it comes through. You want to go back to this part of the recording and go back and see what we did with inverse functions last time. You can scan through the transcript and see where it is. Okay. You know, you figure this is probably about 15 minutes or 20 minutes into the video. So you can find, so you can just, flip through the video, just click through the video until you find this and review it, because I think some of you are going to need to, because there are other things we have to do today. We can't keep doing this, okay? But the essence of it is, what did I do here? I wrote out, I'm trying to do f of f inverse of x. This is f of something. F is the outer function. I write this formula for f of x, and then I replace x by whatever in this formula, by whatever's in the parentheses here. X is in the parentheses here, f inverse of x is in the parentheses here. Meaning I've replaced x by f inverse of x. So I replace all x's by f inverse of x. That statement right there, you need to understand it, ponder it, get open the eye to explain it to you. If you can't understand my explanation, look at the explanations given to you in your videos on Open Math. Look at the text in Open Math. Look at any resource you want to. But understand this. This is absolutely necessary. So what do I do over here? I do f inverse of f of x. Well, I write the formula for f inverse of x, which is here because we derived it over here by switching x and y. There's f inverse of x. And this is f inverse of f of x. So we replace x by f of x. Of course, we do it down here. This is what we get. And on this side, what do we get? We get f of x minus 6 over 2. And then what do we do? What did I do here? Well, I had f inverse of x, and I replaced f inverse of x with the formula for f inverse of x. So f of x is going to be replaced by x minus 6 over 2. And we get this complex fraction. And something's wrong there. It doesn't look like it's going to work out. Oh, it actually wasn't going to work out because I didn't replace f of x by the formula for f of x. I used the formula for f inverse of x again, and that was just a bonehead error. Then you can make it, okay? If you do, go back, look at it again. F of x is 2x plus 6. Replace f of x by 2x plus 6. And we get 2x plus 6 minus 6 over 2, which is 2x over 2, which is just x. So that f of f inverse of x equals x, and f inverse of f of x equals x. It's something you have to know. It's a test for inverse functions. And you're going to certainly get it in your pre-calculus class next week in some of the classes, because I think there's a test coming up in some classes. My class comes a little bit later. So there it is. Now there's more to it, but that's the mechanics of testing for an inverse function. Now, inverse function, if you got a table, it switches x and y. It's the very first thing you have to understand. If you've got a formula And if you got function inverse of x formula, then you can test this for the function and its inverse. The inverse function undoes the function. So if x is equal to 7, f of f inverse of x has to be equal to x. That would have to come out 7, right? Why does it switch the, why does it give you x? Well, if you had two columns, f inverse of x switches the columns. Okay. Then you apply f to that and it switches things back. Okay. Not going to demonstrate that. I'd like to, but we're taking too much time just with the idea of substituting. Okay, now we're taking the time because we need to, but we do need to move on. So be sure you ponder this in any way that helps you. Okay, again, the idea of transformations, we can shift the graph of f of x in the horizontal direction, h units, by using the function g of x equals f of x minus h. Okay, so here's the graph of f of x equals x squared. A graph of f of x equals, let's say, x minus 3 squared. Okay, I'm going to draw another parabola over here. Looks a lot like this one, so they're very well done. But okay, there's a parabola. Now here is your scale. Here's x equals -2. Here's x equals 0. So what's x out here? Show me with your fingers what you think the x coordinate would be here. Okay. Could have done that with two hands, but that had a pen in it. What the rest do you think? What's x? X is -2, 0, 2. What's x here? Not 0, because x is 0 over here. Here's x equals 2. Where's x equals 4? Show me where x equals 4 is going to be. I'm going to start my finger here. There's x equals 0. There's 2. Supposed to scream. No. Yeah. Raise your hand when you think I hit x equals 4. Here we go again. Here I'm at -2. Here I'm at 0. Here I'm at 2. Okay, most people say, okay. So, we can scale this. I mean, not going to be exact, but I think maybe this is x equals 4. Maybe I'm a little too far to the left. I think I should be a little further to the right. Okay. So what do you think x is going to be by the time we get here? Okay, I've got 4. Okay. 2 of you voted, 2 of you haven't yet. Everybody voted. Two of you had x equals 6, and 2 of you were close. X equals 6. And that makes sense. Looks like it might be a little more than 6, especially since I made that one too close. Okay, so what's this function here? If this parabola is an exact copy of this parabola, then this graph would be g of x equals x minus six. Because the graph was moved 6 units in the horizontal direction. If you move the graph 6 units in the horizontal direction, graphing in windows and stuff, or pulling. There's some of you, to others. Has anybody seen it in their class yet? Okay. That's the rule. And that's how it's done. Now, there are other rules. And you got a rule for shifting the graph upwards. Okay, to shift the graph of f of x vertically k units, you would use g of x equals f of x plus k. That means the y values of g of x will be k units more than the y values of f of x, if k is positive. Now, if you're adding a negative, then it'll lower the graph k units. Open math is going to tell you more about that, but that's how it works. This is the easiest one to understand. This is a little trickier. You got to replace x by x minus h. And why do you replace it by x minus h when you're moving it h units? If you want to move 6 units, you replace x by x minus 6. Well, that's because to get the same y value, x has to be 6 units greater. Here. That's why. You can review that statement if you want. You can read other statements. You can ask AI to explain this to you. Just prompt to think, why? Does replacing x by x minus h shift my graph plus h units? Okay. I'm really having trouble understanding this. OpenAI will give you really good explanation. Okay. Won't be exactly the same as mine. If you're in somebody else's class, it won't be the same as the explanation you got there, but the core idea is the same, and it's the core idea that you want to get to. And a lot of times trying to reconcile 2 or 3 different statements forces you to understand. This one is easy to understand. If you've got y equals f of x and you add k to it, then your y is going to be k units higher, right? So I'm not going to say too much about that. That's pretty obvious. So that's like you have a graph of f of x. I'll use the same window because it's an easy one to understand. And it's consistent with everything that Open Math has told you about the toolkit functions. So we're going to use that. Now, let me just take a second here. I'm going to keep the camera running. Okay, now I'm gonna pull this back over here so I don't have to block the board when I'm writing. So if you have the x-squared graph, then the graph of, let's say, x-squared plus 1 would just take all the y values here and raise them 1 unit. And that means I could sketch a line here, the y equals 1, and I go up 1 unit here and 1 unit here, and I can sketch a graph where every point is 1 unit above the point on the graph below it. Every point on the blue graph is 1 unit higher than the point, corresponding point on the white graph. And there's your one function. Put some words around it. Let's say here you've got a graph and you want to move every point twice as far from the x-axis. If we had a little more time, I'd ask you to try to do that, but let's just take this point right here. If we move it vertically twice as far from the x-axis, in other words, move it along this line here. Tell me along this line when I'm twice as far from the x-axis. Are you ready? Watch what I'm doing. Okay, here I'm at the point. Now, when am I twice as far? Okay, so I'm going to watch you, and I'm going to raise my finger, and you're going to tell me when I'm twice as far from the x-axis as this point is. Okay, here we go. Okay, I think I got a signal here, and I got a signal here, and maybe one somewhere in between. Okay, so let's do it again. I'd like to see everybody come down to the same opinion. Okay, ask yourself, is this point twice as far from the x-axis as this one? Or is this point twice as far from the axis? Matter of fact, I'll mark those 2 points because those are the 2 points that I saw people choose. And I'm not saying either one of them is right. They might both be wrong. Okay? One might be closer than the other. You don't know. Okay? Well, which one do you think is closer to twice as far? I'm going to point to them. You're going to indicate some, get your opinion for this point. Get your opinion. Okay? Is that point closer to being twice as far, or is this one? Okay, tell me. Is that closer to twice as far? Well, this is how far it is, right? And this is how far this one is. Okay, so I guess most of you think this one is twice as far, and I think maybe what you're looking at is, well, this is twice as far as this. But when you look at the x-axis, you had to walk from here to here, and then you had to walk from here to here. This is on a scale where this is 10 miles. You'd be walking 30 miles by the time you got from here to here, wouldn't you? So if this is 10 miles, this is 20 miles. That makes sense. Okay, I've seen some consternated looks because, you know, one reason I start my courses by getting into gory details on the graphs is to get people to see what I know people come out of prerequisite courses often not seeing well. Okay. You really got to see um, draw a horizontal line on your paper and draw a vertical line of a different length. Do it quickly because you can't take all day with this. Okay. Okay, now draw a horizontal line twice as long as this directly below it, and a vertical line twice as long as this directly to its right. And I just want to circulate around and see what you think. Okay, very good. Everybody did that. Well, this line is twice as long as this one, more or less. Okay. And this line appears to be, I don't think it's quite twice as far. If I go that far and then that far, well, I guess maybe it is. You know, optical illusions. Your eye follows things and your brain doesn't necessarily interpret the ratios, right? Okay, well, if I draw a line from here to here, the length of that line is how far this point is above the x-axis, right? Now, if I draw a line twice as long as this one right next to it, that's going to be it. If I draw one up here, it's clearly going to be more than twice as long, isn't it? Does that make sense? Okay. So let's take another point of the graph. Let's take this point. Tell me this vertical line when I'm twice as far from the x-axis at this point. Okay. Ready? Finger's going to go. Make a gesture when you think I'm there. Okay, everybody pretty much said there, and that's pretty much right. This line probably stopped me a little short, but my hand was kind of in the way. Should be just a little higher than that, but you get the idea, right? So I'm gonna say, I really think it ought to be here, and that might be what you meant. Okay, well, if I sketch a graph of this, chalk isn't going straight. It isn't me, the chalk is twisted or something. The point is twisted. Okay, anyhow. It's not done very well, but you get the idea that this graph, the points tend to be about twice as high. I didn't do a real good job of it. You get the idea, okay? So I'm going to say now, I should say the points of the graph of y equals 2 to the x, but I don't have time to write all that out. The points of y equals 2f of x as the points of y equals f of x. Okay? So now, if you have the function a f of x minus h plus k, to construct the graph of y equals a f of x minus k, start graph of y equals f of x. And that letter that's smudged up is a. A times further the x-axis. Then shift h units horizontally, k units vertically. Now I say a times further. If a is positive, you're going to move it a times further on the same side of the x-axis. If a is negative, you're going to move it a times further on the opposite side. I didn't want to put all that into the statement, get the idea it goes a times further. But if I was doing negative 2f of x, I'd have to go this far below the axis, because the y value would change its sign. It would not be positive anymore, it would be negative. And now the text and most presentations actually talk about reflections through the x-axis and reflections through the y-axis. So if a was negative, you would first reflect the graph. So I'm going to just put this in here. You say if a is less than 0, then you reflect vertically. That means turn the graph upside down before you do anything else. Now there's more, but I hope that clarifies what you've already seen, if you've already seen it in your class. If you haven't, I hope it makes it easier to understand what you're going to see in your class. Now, I'm going to have to do something about these assignments, because I also needed to talk about the equation of a straight line. And I'm going to make some changes in the assignment, okay? So I'm going to throw in an assignment on multiplying, dividing, and comparing fractions. And I'm going to go ahead and do that right now. So we've done the introduction to transformations. That's going to be due tomorrow. Equation of a straight line is going to get moved to next week. Multiply, divide, and compare fractions. Going to be moved to Monday. And the slopes and applications I'll have to sort out. So right now you're going to see 3 assignments that are due next Wednesday, but those are going to get moved. Matter of fact, I'll move one of them right now. I'm still not sure what to do with the equation of a straight line. Okay. want to give you a chance to ponder the things you need to ponder, okay? If you have questions, please let me know. Okay, so I was saying, most people typically did about half. Okay, as far as getting things right. Some less than that, some got pretty close to all of it. So here's our quiz. I'll start with this one because I can do it on the graph. Okay. And I'm just going to do this quickly. If you don't understand what I'm doing, go back and look at the video from last time because we did it in more detail. Okay. But we did it quickly right at the end of class. So I won't do this too quickly. Okay, the domain. Domain is all the x values that have points on the graph. This x value here doesn't have a point on the graph. First x value that has a point on the graph is this one. And then we got points on the graph all the way up to here. But then we don't have any points on the graph. But every x value between here and here intersect, has a vertical line. Is represented, can be represented by a vertical line that slices through the graph, right? So all these x values are in the graph. So I'm going to say x value from here, and I'm just going to use the y equals 18 line to indicate the x interval, not this x value because we have an open circle around that one, okay? And then what? Well, up to this point, we don't have x values, nothing here. Then looks like we have x values from here to here, and we got dots on the end of it, closed dots. So we have this interval. Then between here and here, we got nothing. And then between here and here, we got points on the graph. Well, that's an open point. This is an open point. So right here is a graphical indication of the intervals. You have to make some estimates. If this is x is 8 and this is x equals 12, I don't think it's really quite 9 here, but we'll just say x is approximately equal to 9 on this line. And x looks like it's between 12 and 16, not quite halfway. So I'm going to say it's about 13 and a half. Then here, looks like x is just a little more than 16, maybe 16.3. And I don't know how I'm going to label this one. I'll label it down here. And this one is pretty clearly x equals 20. And now maybe I can get these. Okay, this one would be 20 to 24. I will say 21. I think it's a little less than that. And maybe 23 here. Those would be reasonable estimates. Your estimates might be off by a little bit. As long as I see that you made estimates or wrote down numbers that make sense in terms of the scale of the graph, I'd be fine with that. Domain is then a closed interval from, well, interval's closed at the left end, so we got a bracket there. It's open at the right end. And then we have a closed interval from 16.3 to 20. And then you have to try to write it in down here. Union with the interval from 21 to 23. Looks like 22 the way I wrote it, but it is a 3. Okay, union, open interval from 21 to 23. And let's make sure I'm writing kind of low there. I'm going to have to zoom back just a little bit so it appears on the screen. Okay. For some reason, I bumped into this thing. That might be why. It's kind of cockeyed a little bit. Okay. Anyhow, there we have it. That's the domain. What's the range? Well, you do the same thing with y values that you did with x values. We have, oh, use blue. The lowest y value we have. Well, it appears to be right about here, and this line appears to be at pretty much the same y value as this one. Now, if you drew it, and this line here is below this point, well, you have some points that aren't in the range, right? Okay. And still see what I need to see. That's a little more than 13 there, but it looks like a little less than 13 here. So I'll just say that's y approximately equal to 13. You see that? Okay. And up here, there's 14 and there's 16. That's a little bit below halfway. So I'm going to say y equals 14.7. Okay. Then up here, is that line straight or is it curved a little bit? If it's curved a little bit, it's a pretty tiny interval. Okay. So I'm going to take the easy way out. I'm not going to try to estimate whether things actually curved or not. And you can .6. Okay, so the range is what? Well, it's a closed interval below because 13 hits a graph here, here, and here, and at the end points. There are plenty of points, an infinite number of points in the graph, if that's a straight line, where y equals 13. So 13 is clearly included, and every point between 13 and 17 passes through at least this curve. But maybe not 17. Again, does that thing hump up a little bit before it comes down to this point or not? Okay. If it does, then you call it a closed interval, but I'm going to assume that it just hits that interval almost in a straight line. So I'm going to assume it's closed 14.7. Union. Now you don't have an interval here. You just got a single value. And I'm not even sure open math addresses that possibility. Pretty sure it would. But what you do is you just say, okay, well, this interval is a set. It's a set of all numbers from 13 to 14.7, including 13 and 14.7. This part of the domain, or range, is simply consists of a single point. So the set, we use set brackets and just write 16.6. And if you're not familiar with set notation, look it up. Okay. Pretty sure the open math materials cover it. But if you didn't notice it in the open math materials, you might just Ask Chat GPT, can you explain set notation to me? Okay. I'm in an early part of a pre-calculus class. I don't remember seeing it. I probably did, but don't assume. Give me a simple explanation of set notation. And if the explanation is too simple, say, thanks, that was too simple. Can you make it just a little more complicated? You can ask those questions and you get really good answers. Then double check that with an authoritative source like the published text. Okay. But if you recognize it and really believe it, if it really makes sense, and you don't want to take the time to leaf through a textbook or flip through it online, that's up to you. Always be skeptical. That's a new word. I gotta figure out what skeptical would be. It's kind of a combination of skeptical and susceptible. If you're not skeptical, you're susceptible. I like that. Susceptible. Okay. I just invented a new word. When Time Magazine comes up with their word of the year at the end of the year, you're going to see that one, and I'm going to get credit for it. I'm just totally confident of that. And I'll ask Chat GPT and it'll say, yeah, sure. All right. Understand what I did here? And understand that was a pretty easy question if you know what the domain and range is. And you had questions in your homework that ask you for the domain and range of these functions, and people did pretty well on them. Okay, very. Fair enough. All right. People did pretty well in this one, but didn't always represent the solution correctly. So I'm not going to do that one yet. I don't have enough room to do it here, and I do have enough room to do it here. Okay. So I'm just going to draw a graph, and I'm going to draw a line for x equals 1, a line for x equals 3, a line for x equals 6, and a line for x equals 9. I'll even indicate down here that, well, my domain should go from 1 to 3, so I'm going to include these values, but not 3. And then from 6 to 9, including 6, not including 9. There's my domain. Now I'm free to draw any function I want. Okay? So the function I'm going to choose is a lot more sophisticated than the function you might choose, because I just want to draw a sophisticated function here, at least sophisticated at the level of a calculus class. But you don't have to understand it. I can draw any function I want between here and here. So between here and here, I'm going to draw a straight line. That's not very sophisticated. Okay. And I'm going to have to put a dot here and a circle here. Are we happy? And now I'm going to put a function here. And this function does this. It's like a sine wave that keeps getting closer and closer. And actually asymptotically approaches, well, anyhow. I could have put an exponential on it too. Could have made it like an exponential sine wave. Okay, exponential function would do this, right? So we start here and we keep making exponentially increasing amplitudes, okay? And down here, we have kind of the reflection of the exponential function. I do that, so you'll just look at it, because we're going to do stuff like that later, but we're not going to do sines and stuff. Yeah, we don't have the functions to do oscillating graphs. That's pre-calculus 2. All right. They're pretty easy to define. Anyhow, okay. Does that make sense? I'm allowed to do that. I didn't ask you then to tell me what the range is. I could have asked you, I could have specified a domain and a range. Well, that wouldn't have been any harder. Just whatever you draw between here and here has to go within the range, has to cover the range. Or between here and here, you got to cover the range. Okay? So that's the idea. Now, when you have a formula, and we do a whole lot of work with functions where you're given formulas. I'm just going to copy that over here. You got, can't go any further. Okay, f of x equals the square root of 2x minus 8 over 4x plus 6. Well, everybody, I mean, a majority of people wrote down, okay, 2x minus 8 has to be greater than or equal to 0. Boom. Right? And maybe you solved it, and maybe you wrote out 4x plus 6 can't be 0 before you solved anything. But I'm going to go ahead and solve this. It's really tough. We had 8 to both sides. And we can add an equality to an inequality. Okay? If this is bigger than this, and this is equal to this, then when I add these, it's going to be bigger than what I have over here. Okay? Now there are rules, but one of the rules comes down to and there are other rules like I violated. I just said, if this is greater than this and this is equal to this, then what I get when I add them is greater than what I get over here. And then I wrote equals because I wasn't thinking. Now it's actually greater than or equal. And I think everybody understands that. Okay. And I think most people got that. Now at that point, I would sketch a graph of this thing. Here's where x equals 4. And this says x is greater than or equal to 4. And then anything greater than or equal to 4, that's represented by the arrow. And that should be pretty obvious picture. Open Math did pictures like that, didn't they? Or didn't they? I'm pretty sure. I've never seen, yeah. And x has to be within the interval from 4 to infinity. Easiest to understand if you first see this picture, but x greater than or equal to 4 means x can be as big as you like. And since we can keep getting bigger and bigger, no matter how big you are, we could double it. Okay. Doesn't take too many doublings to get to really, really huge numbers, and there's no end to it. All right. So x is in the interval from 4 to infinity. Now, also, and 4x plus 6 equals 0 is, I'll just say, forbidden. 3/2. Okay. Well, as it turns out, that doesn't add anything to what we already here somewhere. So we don't even need to mention that. If this had been a minus on the 6, we still wouldn't need to mention it because X would be plus 3/2, which is still less than 4. X has to be both this and this. If it's this, then it's already this. Make sure you understand that statement. That's a statement I want to emphasize because logic can be a little bit challenging. Okay. All right, so do just help clarify a few things. Okay. Yeah, if you had trouble on the assignment, a couple of you didn't get it done. So, if you didn't get it done, go to that have credit page and do it. Okay. What conclusion can you draw if you've earned $200 in 4 hours? What's the first thing you would think of? We'll discuss that in a minute, but think about it for a second. What's the first thing you'd think of? Or if you travel 300 miles in 6 hours, what's the first thing you'd think of to do with that information? Okay, well, I started with, if you earn $200 in 4 hours, then what? And I'm pretty sure we had that on the board, and then we discussed it, and then I forgot to turn the thing on. But what I did was pretty much what everybody said. Because people pretty quickly said, well, that's $50 an hour. Okay. Now, I said, yeah, okay, then you're earning at a rate of, now, it's $200 over 4 hours. Division is easy, you get 50. And you get dollars over hours, which is read as dollars per hour. And you knew that pretty much as soon as you saw the numbers. Okay? Because that's a familiar thing, because most people have worked hourly and understand dollars per hour. Now, I said at the rate of, I really mean at the average. You probably can't read that word, but that word is average rate. So I wrote average rate here. Okay? Because again, maybe I'll say what I said before and get thrown in jail for it. But, maybe you didn't work all 4 hours at the same rate. Maybe you dug ditches at $5 an hour. Okay. And some of you would probably be worth more in digging ditches than others. I think everybody could do $5 an hour worth of ditch digging. Unless you got, if you got a backhoe, yeah. Let's not digress into that, but okay, that comes out $50 per hour. You could work 3 of those hours for $5 an hour. Then you could go write somebody a sophisticated computer program for $185 an hour. Yeah, spend an hour doing it and get paid $185. Then I commented, use ChatGPT to write sophisticated programs without knowing how to code. You would have to know how to structure the logic. Okay. I comment, I'm pretty good at structuring logic. I've some pretty big well, I wouldn't say big programs in the scale of big commercial programs, but things with some convoluted logic in them. Okay. Because most of my logic is convoluted. So I could write a program take over the world using ChatGPT. But as I said before, I promise not to do it. So if you're disappointed in that, you have a better opinion of me than you should. If you're breathing a sigh of relief, you- your judgment is just about right. Okay. If you travel 300 miles in 6 hours, then what? Well, people average, the answer, well, it's 300 miles over 6 hours. You divide 300 by 6. Okay. And that's the first thing somebody thought of. But why would you do that? Well, comes out 50 and it's miles over hours. So it's miles over hours. Pretty easy concept. If my wealth increases from, we use these numbers, $200 to $500 in 4 days, then we'll discuss this briefly. Okay, well, this causes a little bit of confusion. Well, I'm going to say then by $500 minus $200, which is $300. In 4 days. Average rate equals change in my wealth over the time required, which is $300 over 4 days equals 4 into 375. And I'll write dollars per day. Okay. Now I'm going to change in 4 days to that's between 9/11. It is 9/11, isn't it? Some of y'all weren't alive then. Okay, I want to ask you who, because I don't know. I don't want to get personal information that I don't have. Okay. Seems pretty recent to me. Um, Okay. I heard about it in the gym, I think. The owner of the gym was talking about it. The owner of the gym was an ex-professional basketball player. Not in the NBA, but in the worldwide league. He's still making pretty good money. Uh, and he could still really play, but it was his first year not playing. He's the first guy I ever saw with a plastic mask on his face in the Sweet 16 game, the team he was playing for. They didn't watch all that much basketball, so it's kind of a neat coincidence to have actually seen him. But the point is, he was a young guy at that time, and that was 24 years ago. He's middle-aged now. Still wouldn't want to try to play basketball against him, even if I was in my prime. Okay. Because I wasn't that good a basketball player. Okay, anyhow, just a little color there. And, it's a bad thing. Okay, 9/11 and 9/15. Now that is 4 days, right? So what we're saying is the average rate wealth change here in well, I'd have to figure out how many days in the year there are up to the 1st of September. And then add, let's see, that would be about 270 days, but less 3 for February and plus a few, maybe 371 days. Maybe I'm right, maybe I'm wrong. Okay, you can figure it out and go find a calendar. So that would be the 381st day of the year, and that would be the 377th day. What I just said isn't at all right. This would be the 382nd day, and this would be the 386th day. So I could say day 386 minus day 382 of 2001, if you don't want to try to do subtraction from 9/15 to 9/11. It just comes out 15 minus 11. Yeah, we don't want to get hung up on that. The point is, we have the same information. Instead of time required, I'm going to write the change in time. That makes sense? The change in time between this day and this day was 4 days. And I thought that was all on the board. But anyhow, we start with my wealth changes from 200 to 500 in 4 days. The average rate is the difference here, which is $300 divided by the 4 days. And we get $75 per day. It's just a little more complicated than this because you got to know, how much money did you earn at that time? Well, that's the change in your wealth. And maybe that's not the money, take how much you earn minus how much you lost. That's how much your wealth changes, okay? Change in wealth over change in time. Then I said, okay, between 9/11 and 9/15, just because today happens to be 9/11. 24 years later. So if we write it this way, we see that change in wealth is $300. That's pretty clear. And now that we can say the 4 days is the change in time. We divide the change in wealth divided by the change in time. Okay. Now that word I just had in there is average. I can't even read it. But this is an average rate of change in wealth with respect to time. It's change in wealth divided by change in time. Okay. So we can say that it's a fancy way of abbreviating rate of change, ROC of wealth with respect to time is change in wealth. To give myself room to write that over change in time. If I have a graph, and this is day 382, if I'm right about the, it's not 382, it's 282. Did I say 3? 282. And this is day 286. If I can make that 8 even worse. In their right mind could read that. Let's see, 282. Then that's time. So we're on a graph of wealth versus time. The wealth goes from $200 to $500. Well, we'll call that Y. And we'll use T for time in this case. Okay, Y equals wealth. And I can even write in dollars. Time. Now I wrote days down here. You can't read it, but it's a good thing to specify. You can look at the video and see it a little more clearly. And it's pretty much all there, but let's make sure. Okay. Then this point here represents the fact that on day 282, our wealth is $200. And this point represents the fact that on day 286, our wealth is $500. Okay. Now, I'm going to draw what I call a fundamental triangle. Now, this arrow here, how long would you say that arrow is? Show me with your fingers, if you know. On the scale of this graph, it's going that way. How far did it go that way? Give you a hint, it's just as long as this arrow, because these are vertical lines and this is horizontal. How long is this arrow? It goes from what to what? Yeah, it goes from day 282 to day 386. So the length of this arrow is 4 days. Okay. What's the length of this arrow? Well, you can't show me with your fingers, you don't have enough, but it's 300. That means you go 3, 0, 0. This is Now, this is plus 4 days, and this is plus $300. It could be that my wealth went from 500 to 300, in which case this arrow would be downward. This point would be higher than this point, so you go over and down. Okay. And I would say my change in wealth was negative $300. Okay. Now I make a straight line here and figure out what's the slope of this line. Right. So what we want to do is we want to find the slope of this line. And I just asked, okay, what is slope? And somebody said y equals mx plus b, which is getting close because first place, you remember one of the standard forms of the equation of a straight line. That's good. We're going to be doing that shortly. Okay. And m is the slope. And then somebody else said, well, it's rise over run. Okay. And everybody remembers here in rise over run. I said, there's also a formula y2 minus y1 over x2 minus x1, which is what open math is going to try to drill into you. But you're going to remember rise over run longer than you're going to remember the formula. Because everybody remembers rise over run. Nobody acknowledged remembering the formula, although I bet some of you do. But I'll bet you more people recognize rise over run than the formula. Okay? So the idea is rise divided by run. Now, as I go from here to here along these arrows, can you tell me what's the rise and what's the run? Okay, so I got a good answer. Rise is the 300, the run is the 4. Actually, rise is 300 days. It's not 300 days. What's the matter with you people? I don't know who wrote days up there, but it wasn't me. Actually, it was. It started with D. Once I got the D down there, I was on my way. Okay. The rise is $300 and the run is 4 days. Okay. Everybody understand that? So what would the slope be? Okay, so slope equals rise over run is $300 over 4 days. And that equals you can distinguish this from the other stuff. I have to write it between the lines. I accidentally leave myself enough room. But it's $75 over days. We write that as dollars per day. So what do we do with that? We got enough chalk there. Okay, that is I've written $75 per day here. And I've put a box around it. Now, just by looking at that triangle and the labeling, you see pretty much everything you need to see. You see that it took 4 days for my wealth to increase by $300, and that the average rate of change then, or the slope, because it is the average rate of change, is $300 over 4 days or $75 per day. And that was the average rate of change that we got using the definition of average rate of change. Okay? This is really important. This average rate of change idea, or the rate of change idea, is the entire foundation of first semester calculus. It's all first semester calculus really talks about, although it talks about a lot of machinery to develop an instantaneous rate of change that we're not going to talk about. Okay, that's the first thing you do in calculus. People come out of calculus not knowing that it has anything to do with rate of change, even though that's the primary thing it has anything to do with. Okay, and that's despite the best teaching in a really good course, because they lose the forest for the trees. There's a lot of rules and manipulations you got to learn in calculus. It's not easy. But they lose track of the fact that it involves rates of change. And then they come into my physics class and they got to deal with rates of change. So we got to reinforce that. When I took calculus, I maybe had a little better idea than most about the fact that it was rates of change. But I didn't relate it to physics real easily. Because of course I was taking physics at the same time as calculus, which everybody at my university did. Okay. There's actually Institute of Technology, but part of a university. Okay. So all I'm saying is I'm trying to make something really clear. It should be important to you if you have a calculus course in your future, and it's important anyway, because rates of change are all around us. Okay, if you're speeding up in your car, you've got a rate of change of speed, which is acceleration. Accelerate too fast and your tires are going to spin. Accelerate too fast for too long, you're going to be speeding. Okay, stuff like that.